This presentation is to introduce you to something called IEEE Explorer. So first of all, you need to be hooked up to VPN, or you need to be at NTNU. Because that will give you site access to IEEE. So let's start Safari. And okay, IEEE Explorer.IEEE.org. So this is a database that contains more than 5 million items. And it's basically pretty much every interesting paper on electronics ever. But the fact that there's 5 million items means that it might not be that easy to find what you want to learn about. So let's pick a topic. Let's say you wanted to learn more about a particular type of circuit. Let me see. So maybe I want to learn the latest and greatest on DC-DC regulators. If I do DC-DC regulator and I search for that, let's see how many we find. Okay, so I found 4,000, almost 5,000 papers. Right, so I can go back to the earliest paper. That's usually quite fun. So if I go back to 1903, 1905, synchronous converters and motor generators, direct current generator for constant potential and variable speed. That's quite interesting. It's sort of really old stuff. Actually, I want to have a look at that. Let's see what that is. Synchronous converters and motor generators. There's that pictures. Huh. That's interesting. So one of the cool thing about finding sort of really old papers is that they don't take anything for granted when it comes to knowledge about the topic. So for example, the first paper explaining something, first paper explaining something will usually have a very good description of how it works, because nobody knows how it works yet. But this is not exactly what we wanted. But let's say if I changed it a bit and I happen to figure out that these are often called buck regulators. I don't know why, actually. So 1911, okay, let's see what I find there. Let's do 20. Nah, still about motors. Not that weird. I mean, there's no solid state yet, but let's go to the 50s. Nothing there. Let's skip to the 60s then. Oh, didn't work. All right, yeah. Now I have to go back there first. It's not the best search engine in the world, but let's go to 1960s. That's sort of after the transistor has been invented. Okay, still nothing. 1970s. Okay, so something happened in 66. Let's have a look. Ah, here we go. Low frequency characterization of switch DC-DC converters. Let's see if, oh, that's interesting. There's a guy called Buck. Maybe that's why it's called a buck converter. Who knows? Actually, let's try to figure that out. All right, so you can't click that one. Sort by relevance? No, let's sort by oldest first. 1911, Middlebrook. Okay. Central emergence page. Yeah, so here now we're getting something. So let's have a look at this one. And let's have a look at this one. So this talks about something central inverter in a power system, space power system. Does it have pictures? Takes too long to read the thing. Okay, so here we have a DC input. But that's not entirely what we want, because here we get an AC output. But then elevated DC link inverter circuit. So how does this work? So here we have L1, was that a DC input or? No, it's sort of AC output. So it looks like they're actually generating AC signals. But it is actually a description of buck boosts. So that's quite interesting. So basically these type of buck and boost converters are used to increase and decrease, or you go from 5 volt, for example, down to 1 volt. And by going back in history, you can find sort of the earliest papers that describe why did they do this, and then sort of what was the problems. And like in this thing, it's very rare that we now go from a DC to an AC, for example, at least for integrated circuits. But the maths and a lot of that will be similar. So we go to switch DC converters, and this name you should actually note down. Middlebrook has multiple things named after him, among others the Middlebrook technique. Okay, block diagram, power stage, and controller. So here we have something switching, and we have a power stage. Let's find, yes, now we're getting somewhere. Okay. Circuit configuration or switch power stages, buck, boost, and buck boost. Okay, so first one here is a buck. Here we have a voltage source, and we have a switch, and then we have a load. And the way this works is that when we close the switch, then there will be a voltage here, and the voltage difference between this point and this point will set up a current through the inductor. Now, as the current builds up in the inductor, the voltage will increase at this point. Now, and then at some point you turn off the switch. Now, since the current in an inductor cannot change instantaneously, then it has to be pulled from somewhere. And what actually happens here is that it's pulled from ground via this diode. So there's still current flowing in this circuit, even though you're not supplying it from this battery. And the really neat trick about these type of converters is that they convert power consumption on this side to power consumption on the battery. So you can, if you spend 1 milliamp at 1 volt and you have a 3 volt battery, it actually turns into 0.3 milliwatts, for example, or 0.3 milliamps. So you divide by the voltage ratio, and that's really nice in integrated circuits. But this is probably one of the first papers on bucks, and the good thing about these type of papers is that it will explain the fundamental theory very well. While if we go the other end, let's see. So there's a PhD thesis. There is actually something here, something earlier, but not much. Bose compression. Yeah, that's probably the. So this is probably one of the earliest papers on these type of buck boosts, or maybe a summary paper. So what I was about to say is that if we go the other end and you search for the latest paper on buck boost, let's do only 2020. How many papers do we find? 170. That's too many. Then we need a selection criteria. So if you want to find for circuits, the most or the best papers, you want to look in the Journal of Solid State. Start there, and then you can do the International Solid State Circuit Conference, and then the other solid state circuit conferences. And that's going to be the same thing for most other topics. So for example, if you wanted to figure out everything you want to know about transistors and FinFETs, then you have to first figure out what's the most reputable journal, what's the best journal for papers on that topic. Now, once you got that, then it should be pretty easy to find papers. So here we have a high voltage dual input buck converter achieving blah, blah, blah. So have a look. Let's have a look in here. Because I would expect that in the latest paper, there will not be too much extra information on how these type of systems works. So here, let's try and read the introduction. This article presents a high voltage dual input buck converter for triboelectric energy harvesting applications with maximum power point tracking for TE nano generators. What the hell is that? Who knows? An important characteristic of TNGs is their AC output voltage with different positive and negative peak voltages. Thus, the proposed system harvests each half wave with a dual output rectifier for better extraction efficiency. Okay, so this is about energy harvesting. This energy harvesting system has some special characteristics where you actually need some special, what was it called? Half wave harvesting. Okay, but there's supposed to be a DC-DC conversion here. In here. Yeah, so here we can see there's some switches and the inductor at the output. So this is actually the DC-DC converter. So you have pulling high, pulling low, and then the same thing. But this paper will not explain this part that well. It will assume that people will know how bucks work. So you can find the latest techniques and the most sort of fancy things and good design ideas in the latest papers. And it's always good to look at the latest papers before you start designing a current, because start designing a circuit, because that gives you the best sort of latest ideas. But if you want to learn, if you want to understand, the most recent papers are not the best. What you want to do is you want to go back to the originals. And it looks like this is actually a pretty early original on buck converters and boost converters. Because the good thing about this type of thing is that the maths stay the same. It's, after all, just electronics. Okay, so I hope that helps you find, and you can also search for authors in here. And I have to do a slight self-promotion, I guess. Or I want to do a slight self-promotion. If I put my name in, and click myself, and then you can also find the papers that I've been a part of, and also some of my, well, my PhD student or students' papers. So that's fun. When it comes to analog design, especially nanoscale technology, this is a paper I would recommend. Actually, and it's going to be in the curriculum. And that we're going to go through a bit more detail, why this is important, what's the different effects, and so on. Okay. Have a great day. Bye.